Um, Welcome, guys. Welcome to the next Gen I with Sai YouTube channel. Uh, if you miss previous lecture on NLP, okay, so let me tell you, we have started the series of NLP for everyone. NLP for everyone. So I request, I have started this, and there are a couple of lecture to this. The purpose is very simple, that everyone can understand NLP, at least the language of NLP. At least everyone should master the basic of NLP in today's world, and that is the purpose. I have already recorded the first lecture. If you miss that, I would suggest please watch that. And if you feel that I knew the basic of NLP, I wanted to little bit move ahead, then please feel free to watch this video or this lecture till end. Okay. So once again, welcome and thanks for clicking this video wherever you see this thumbnail and watching out. Please request you to watch this till end. So let me tell you what are the topics we are going to cover in today's lecture. The first topic we are going to cover the machine learning for NLP. Okay. In my previous lecture, I have explained you how NLP come into the picture, what was the history, and how machine learning is evolving around the NLP. But today we are going to see in detail. Second, after that, we will see some text pre-processing stuff that we need to do while working on the NLP. Third, we are going to learn about the tokenization. Okay, I already explained what do you mean by tokenization in my previous lecture, but anyways, I'm going to cover today also. And then something is stemming, that's something you need to know in detail, and the lemmatization. Specifically, I'm going to cover what is stemming, lemmatization, the difference between them, what is the advantage of stemming and when to use, what is the advantage of lemmatization and when to use. So these are the topic that I'm going to cover in this today's lecture. Again, this lecture also bit lengthy, okay, but this is very important to cover in detail. Okay. So let's start with the machine learning. I hope you already know what do you mean by machine learning. So that definition I'm not going to cover. But generally, machine learning is classified into three steps. Okay. So let me first write down the headline, that what we are focus on. So machine learning for NLP. So machine learning broadly, three types of machine learning we have, subtypes I can say. First is supervised learning, second is unsupervised learning, right? And the third is called as the reinforcement reinforcement learning. The supervised learning is something generally we call as a task driven type of learning. So in general, I can say in supervised we ask one question, this algorithm asks us, teach me what to learn, teach me what to learn. So we are giving input data, we are giving output data, and based on that, model do some learning, some make the model, and then same model we use to do some task based on the new data. Okay, so general supervised learning task we are doing classification, and second is called as the regression. If I say classification, general example is the price of the house. Sorry, not price of the house. To classify um, into the positive sentiment, negative sentiment, or the neutral sentiment. right? So these are come follow under the classification type of learning. Regression, house prediction, right? So you are giving the data like area of the house, length of the house, and then what are the other number of rooms, and then price associated with that. Model will learn on those, and whenever you are giving new data of similar feature, the model try to predict. So in the supervised model already know the data, learn from this, and you do the sum task. This is called as a classification and regression. When I say unsupervised is called as a data driven. Data driven means is a generally a clustering type of problem. Means what? Here algorithm will ask one question that I will find I will find out what to learn. So you are here. You are not asking model what to. You are not giving a model output. You are just giving a data, but no output. And on their own, models understand do the some kind of clustering stuff. Okay, so the data which are close to that data make a group, make a cluster. So similar type of data are close to each other, make a one cluster. Similarly, it make the another cluster which is similar to that nature. Okay, so this is something called as a unsupervised or clustering. Okay, third is the reinforcement learning. Reinforcement learning means I will learn. Okay, I will. Okay, so let me first. Reinforcement learning is nothing but that learning from mistake. Learning from mistake. So in reinforcement learning, you're not giving any data, you're not giving any input plus output data like supervised or any data like unsupervised. You are just asking to do this. Okay. Now in this, you don't have any data. The best example here is that playing a game, right? You are just asking the model to play the game. Now how the model will learn? Model will learn from its mistake. Okay. It will play first step. If it is fail, it say it is fail, understand how why it failed, and do the next action. Okay, so this is called as a trial and error method. So these are the three broadly classification in the machine learning. One is a supervised, second is a unsupervised, and third is the reinforcement learning. I hope you understand. Now let's go little bit depth. Okay, when I say supervised learning, in supervised learning there is a classification, right? So what type of classification NLP task? That is, I can say sentiment analysis, right? Is one of the, you are giving some movie review and wanted to classify whether it is a positive, negative, or the neutral. So it is a supervised NLP task, right? Second is the uh, there is also a regression task. Okay, what is the regression task for NLP? Let's say there is a news and you want to predict the stock price of the stock price, right, based on the news. Okay, or based on some news and plus other data. Okay, so this is also a regression type of for the NLP. Now let's understand few more example for the unsupervised. In my previous lecture I mentioned about the topic modeling, right? So what is the meaning of topic modeling? I am giving a data and wanted to understand what topics, okay, which topic, this data is related to the which topic, right? Or I can say anomaly detection. Okay, so this is the data I'm passing. This is the something data and want to understand what are the anomaly in that data. So this is also one of the another type of the unsupervised learning. Okay, so it clubs the similar data in one cluster, another similar in another cluster, another in another cluster but there are if some anomaly which is not a part of this way it can understand these are the anomaly in the data. So this is also a unsupervised type of NLP technique. Okay, so and then reinforcement learning is something that advanced technique that we will not consider here, but it is a part of in today's your generative AI. Most of the generative AI models are developed using the machine learning and machine learning plus reinforcement learning. Okay, but when I consider the machine learning for NLP is generally classified into the majorly three steps. What are the three steps? The first step is extracting the feature from text. Okay, when I say machine learning for NLP, it generally broadly classified into three steps. First is extracting the feature from text. Second, using feature engineering or using the feature representation. So once you extracted the feature, then we use those feature representation to learn model, to learn model. And the third is that once the model is learned, we will evaluate and improve the model. We will evaluate and improve the model. So this way, these are the broadly three steps for any machine learning for NLP. Okay, now we will see how we can extract the feature, how we can do the feature representation. Okay, these are the steps can be said, but these are the three majorly steps used in a machine learning for NLP. Okay, now what are the different machine learning algorithm is available if I want to use for NLP? So you can use first is the, so what I'm now trying to say, algorithm that we can use for the, so let's understand what are the algorithm is used for the NLP. The first algorithm is called as a Navy bias classifier. Bias classifier. Second is the logistic regression classifier. Okay. First is the Navy bias classifier. Second is the logistic regression classifier. Third is the SVM, that is support vector machine. Fourth, all these are the supervised machine type, supervised machine learning model. Another is the K-means clustering. This is a unsupervised machine learning model. And the fifth is a association rule mining. So by the way, we are not going to learn all these machine learning model in detail because that is not the context of this lecture series. Probably I will create the another lecture to understand this algorithm in detail. But I just wanted to give what are the machine learning algorithm can be used for the NLP task. Okay. Now, as I mentioned, there is a reinforcement learning, right? Sometime before. So when I go to the reinforcement learning, there are many applications currently developed for under the reinforcement learning. What are they? So the first is the text summarization. Okay. Now, can't be possible using the unsupervised. Yes, it can be possible, but the quality and the improved summarization is possible using the reinforcement learning. Second is the chatbot. So whatever currently the chatbot we have, okay, we are using as a chat GPT. These are the built based on the reinforcement learning technology. Okay, so this is what something we have talked about the uh, machine learning. Now let's focus on the next topic called as the deep learning for NLP. So if you have any question, doubt till now, please feel free to do the comment as I want to cover most of the talk in one video. So I'm not making any sub part in that. Okay. Still, if you have any question, please feel free to to the comment in the comment section. Okay. Now next I'm going to cover it's called as a deep learning for NLP. Now what is deep learning? Why deep learning is popular? As I say in the previous task, when the deep learning come into the picture, the accuracy or the scalability or improvisation is much more than the machine learning. Similarly, when machine learning came into the picture, it is having much more good quality output as compared to the rule based method, that is heuristic based kind of thing. But deep learning is giving more. The people who don't know what is deep learning is a sub branch of the artificial intelligence or sub branch of ML, where we develop the neural network. So I'm not going to explain this in detail, but just to give the hints, this neural network is a combination of activation function, which is have this is something called as an input layer. Then there are some uh, multiple hidden layer, or I can say middle layer. Okay, these layer called as activation, which has some dimensions. Okay, uh, then finally, okay, and then finally we have called as a output layer. Okay, and then this output layer again adds connected to some you know so I'm not going to connect each and every thing, but we'll have separate lecture how this deep learning model works. And then we have something called as a loss layer. The loss layer, we use some kind of loss function. For example, we can use cross entropy or other loss function to calculate the loss. Okay, and based on the loss, there will be a back propagation. So when the initially does, this is called as a forward propagation, and then when it based on the loss, it will adjust the weight of this layer and the activation function. This happen through the backward propagation. But what is deep learning? Deep learning is something you can say it's a neural network, and mostly in the complex activity like a virtual assistant or vision for driverless car or the face recognition. All these all these application develop using this deep learning technique. Okay, but let's not go into the depth because it requires another as I mentioned, why the deep learning is important. Now remember, okay, if once you increase amount of data, okay, once you increase amount of data, and my y-axis is the performance. Why? Y-axis is performance. So my convenient machine learning model or older model start not giving the improved result, while in case of deep learning it perform very well. So these are my deep learning. Okay, so result is good as compared to machine learning. However, older machine learning model not giving the good, and that's why we are using the deep learning, as performance is very high when you increase the amount of data. Okay, that's the reason we are using the deep learning for NLP. Now I hope you understand the importance. As we see some of the algorithm in machine learning, similarly let's see some of the algorithm used in the deep learning, okay, for NLP. The first is the recurrent neural network, that is called as a RNN. Second is the LSTM, that is uh, long short term memory network. Third is the convolutional neural network, that is called as a CNN. Okay, convolutional neural network, that is CNN. Fourth is called as a BERT, that is a transformer based model. What is the full form for BERT? Bidirectional encoder representation from transformer. And the fifth is called as a GPT, that is chat GPT. Okay, chat GPT. Why chat GPT? Because chat GPT uses the GPT based model. Okay, what is the full form of GPT? It's a generative pre-trained transformer model. Pre-trained transformer model. So these are the some of the deep learning model is used for the NLP. What we are saying, these are the deep learning model for NLP. Okay, great. Now, as of now, we understand few things. Okay, machine learning, deep learning. Now let's understand text pre-processing for NLP. Okay, let's. So now the topic is text pre-processing for. Okay, so first we are going to see some of the first step is the transformation process. What is the first step in that? Transformation. The text transformation process. Now remember, this text transformation process follow some steps. So what is the first step? First step is they take the color. Yeah. Okay. So they first use the raw text corpus. Okay, raw text corpus means your data, your text. Do some pre-process on that. Okay. After this pre-process, there is a output is a pre-processed text. Okay. So you have the raw text. After the raw text, there is some pre-processing happen. Will give the pre-processed steps. After the pre-processed text, we have tokenized text. What we have? Tokenized text. After the tokenized text, we have corpus vocabulary. Okay. So, do you know what is tokenized text? I earlier explained in my previous video, tokenized means splitting the text. Okay. Whatever sentence you have, you are splitting those sentences into the word or sentence, this thing. Okay. This is called as a tokenized text. You are splitting the sentence into the splitting the text is nothing but the tokenized text. Once you have the tokenized text, you will have the corpus vocabulary. Okay, so important, corpus vocabulary is nothing but the unique words. You are maintaining the vocabulary for that. And then after this corpus vocabulary, once you have the unique word in this vocabulary, because see, whenever you're sending the data, it has a repetition of multiple words, right? You wanted to get the unique word and you are making the vocabulary of those unique words. And once you have vocabulary of those unique words, you assign some numbers to those unique words. Okay, and those numbers you are assigned to the text. So now you have text representation. Okay, because at the end machine understand the numbers, not the text, and you assign some number to this and you convert those text into the numerical form. So this is the some transformation process, okay, we are using, okay, while doing the this. Once this done, then the next step is the feature engineering, that is the converting the text into the number, that is called as a feature engineering. Okay, that we will see in the next lecture, how once I have got the text representation, how I can convert that text into the features. Okay, that will see in the feature engineering part. Okay, now I hope you understand what the majorly the transformation process. Okay, if I want to give example, let's say I'm watching the next gen AI with side channel. So this is my text. I'll do some pre-processing. What are the pre-processing, that I'll explain in a minute. Then I convert this sentence into the splitting in the tokens. I'll split by space or this I will also explain in a minute. And then I'm making the unique vocabulary, mean taking out the unique words or character from this and make the vocabulary and assign some number, and I'll then my whole text I'll do the representation. So this is the text transformation process I am doing. Okay, now when I say text pre-processing, what are the text pre-processing steps we are doing? Let's understand in the bit more detail. But I have here I'm giving you the overall things. Okay, so first text pre-processing that we are doing is called as the tokenization. Okay, so let's understand what is tokenization. Tokenization is nothing but the breaking down a text, breaking down text into smaller unit, into smaller unit. Okay, smaller unit, it may be word or it may be a sentences. This is called as a tokenization. Okay, there are ready-made libraries available through which you can do the tokenization. Second step, that is called as a normalization. Normalization means what? I want my sentence or my text into one form. And how I can make? By making to the lowercase or uppercase, right? So I want my all text into the one consistent format. Okay, when you convert the text into the consistent format, then it is called as a normalization. The third is called as the stop word removal. What is called as a stop word removal? Stop word removal means there are few words, right? The, and, okay, um, okay, there are different such a words are available, okay, which is not adding any meaningful things in your text, right? Text representation. So you want to remove this. So this is called as a stop word removal. And the next is called as the fourth is called as a stemming or lemmatization. Okay, definitely we'll see in detail these two things. But what is the stemming or lemmatization? To reduce the word to their base form, to their base form. Now when I say to base form means what? For example, let's say running. Okay, what is the base form of running? Is run. Or let's say walking. Okay, what is the base form of walking? Walk. So we want to convert this into the base form. This can be achieved through stemming or lemmatization, right? So these are some pre-processing steps are applying text pre-processing. One is a tokenization, normalization, stop word removal, and the stemming and lemmatization. Now, when I say tokenization, okay, uh, this tokenization can be achieved through popular library, something called as NLTK, Spacey, or even NLTK and Spacey are available in Python, but this can be achieved through Java as well. Java provide one famous library called as a Stanford uh, Core NLP. Core NLP. Okay, so using this you can do the tokenization. Stanford Core NLP. Okay, if you wanted to achieve this in the Java, so through this also you can do it. Now let's do some practical, okay, so that will be not feel boring and you also see through eyes how this works. Okay, so we will use okay, let me use this. We will use word tokenization. So the word suggests that you are converting sentence, the text, or splitting the text word by word, okay, with the help of space. Okay, so to do the word tokenization we are using the NLTK library. Okay, so let me share my Google Colab so that I'll explain. Okay, so as you can see here, okay, I'm using NLTK. For the NLTK, you need to download the library called Punkt. Okay, so this will download the library. Here is my text. Let's say I'm watching the NLP for everyone lecture by Sai, and then I uh, import the class word tokenize from the nltk.tokenize, and then I'm passing this text into the word tokenize. As it is a word tokenize means I want my this sentence to be split or tokenized by the white spaces, because in English if I separate anything by space means there are the two different words. Okay, so when I separate by spaces, so see my sentence is tokenized in this way. So I am watching NLP for everyone lecture by say everything is a former separate by space and it is former list. Okay, so this is the call as the word tokenize. Similarly, I can do this using the sentence tokenize. When I say sentence tokenize means if there is a text, okay, which has a two sentence, so I am splitting the text with the by the sentence. Okay, now here you can say my text, this is one sentence, this is another sentence, right? So if I pass this text into the sentence tokenize, it will get separated out, and there are now my list has a two sentence. Here the text is splitted by based on the word. So this is the difference between the word tokenize and the sentence tokenize. I hope you understand this. Okay, great. I'll share this notebook. Okay, please feel free to use. Okay, so don't worry about that. Now let's move to the now. Is the only two tokenizers available? No, there are many tokenizers available. So what are these tokenizers? So let me note down all the tokenizer for you. For the enough, as we have less time, I cannot cover all the tokenizer. I'm just giving so that you can try at your own. Okay. So word punct tokenizer is available. Second, reg X tokenizer is available. What is regex tokenizer? So you are using regular expression, okay, and using the regular expression you can split the text. Third is a blank line tokenizer. So wherever there is a blank line, based on that it can split the text into the it's splitting the text. Then there is a tweet tokenizer. Okay, as you know, in the tweet tokenizer, based on the hashtag or based on the mention, it will split the text. And the fifth is called as a tree bank word tokenizer. Okay, so this tree bank word tokenizer, uh, actually it is designed for pre-processing text in a pen tree bank format. Okay, so the pen no it has some specific, so it will split the text based on the part of speech tags. Okay, it will split the text based on the part of speech tags. Okay, so this way these are the tokenizer is available. You can do research on this and you can use if you want. Is this enough for tokenizer? No. So these are the tokenizer are the I can say oldest way to splitting the text. But when we are going to the transformer based model like BERT and the GPT, let me just okay, when we are going the BERT or GPT, okay, these are the transformer based model. They promoted the advanced tokenization, advanced way of tokenization. Okay, so what are the advanced way of tokenization? The first is this. The first is the byte pair encoding. One, byte pair encoding. Second is the word piece tokenizer. Okay. Third is the sentence piece tokenizer. Okay. So these all are uh, state of the art model uses these kind of tokenizer. Okay. By the way, I'm not going in detail, but just to give the intuition, the byte pair encoder is a something that it will convert the text. Okay, just for your understanding, probably I need to create a different lecture for that because it is itself very lengthy. But the byte pair encoding is a something it will convert the text into the individual character. Okay, individual character. Okay, so the not word character, it is an individual character. After that, so it majorly fall into the three steps. One is the pre-processing, then merging, and the third is the iteration. Okay, so in pre-processing it will do the splitting based on individual character, and then they try to merge the character and check it out their frequency. Those after the merging, those frequency occur majorly, it will save those merge word into the vocabulary, and this iteration goes on. How much? Till the desired size of vocabulary is achieved. Desired size of vocabulary is achieved. Till this process is going. I'm just giving the overview, not in detail, okay? But this way, the byte, this is also shortcut. What is the short form of this byte pair? BPE. Okay, so using this way, they are for doing the tokenization. So all are the state of the model using these are the kind of tokenization. Probably will make another video to for each and every tokenizer technique. Okay, now what is the advantage of byte pair tokenizer? Okay, let me just go a little bit up. Okay, so what is the advantage of using BPE? The first advantage, it handles the unknown words. Okay, before all these tokenizer, word tokenizer, sentence tokenizer, you should know the words. But there are some texts you don't know, or maybe your vocabulary doesn't know. So for that, you can use the BP, which handle the unknown words. Second advantage of this is improve the efficiency. What it will do? It will improve the efficiency, right? Because what happened? The original vocabulary size is smaller. The BP vocabulary, sorry, not original. The BPP vocabulary, because of this methodology, it is a smaller than the original vocabulary. So search criteria or search pace is getting reduced. So therefore, the efficiency is improved. Okay. So these are the some pre-processing way. These are the some tokenization technique we are using. The second step is called as as I mentioned earlier, it's called as the normalization, right? So what is the advantage of normalization? As I say, the consistent format. Okay, so you can convert all your uppercase to the lowercase, right? And then we thought about the stemming. So what is the stemming? Again, to reduce the word to the base form. Okay, to the base form. Then what is the lemmatization? Lemmatization is also converted in the base form, but make sure that this base form to their dictionary form. Okay, in stemming doesn't matter whether the word, for example, when I say running to the run may not contain your dictionary, right? But this is not the case in lemmatization. They convert the word only those which are to their dictionary form. Okay, so this is called as the lemmatization. Now, third I mentioned is the stop word removal. Okay, so as I mentioned, there are few words. Okay, so if you want to see the stop words, let me show you so that you can see what are the stop words are available. So let me see. I already imported the words, so stop words. Okay, dot corpus in. Okay, so if I want to show you the stop words, you will able to see. Okay, so okay, I will need to download the stop words. So let me download the stop words first. So this, download this. Okay, download is done. See, okay, so if you see, these are many stop words are same, so, then, very, can, will, just, don't, should, shouldn't. Okay, so these are the stop words are available. Okay, so these are not adding any value when you are doing text processing. So we wanted to remove these stop words. Okay, so these are the stop words we can remove in our text pre-processing steps. Okay, great. Next, text preprocessing steps that we can do is called as a punctuation removal. Okay, after, so let me write down here. Sorry for the bad handwriting, but I hope you understand. So after the lemmatization, we did the stop word removal. After the stop word removal, the next pre-processing step is called as a punctuation removal. Okay, punctuation removal means what? Comma, exclamatory mark, percentage sign, star. So these are not adding anything to yours. So these are the removal we can do. Okay, so this also the library is available. You can use the library and do this removal. Apart from that, there are some text cleaning things that we need to do. What are the text cleaning things we can do? It is a something called as a address error. Okay, so remove the special character. Okay, there are some special character, right? Like at the rate, hashtag. These are special character that we need to do. Even expand the abbreviation. Expand the abbreviation. For example, AI. Okay, so generally people don't use artificial intelligence, so we want to convert this AI. Wherever AI is there, we need to convert into the long form artificial intelligence, because model don't understand the AI, what this mean by AI. So we expand those. Also we need to do the spelling mistake. Okay, so wherever there is a typo, okay, wherever there is a typo or a spelling mistake, okay, so we need to work on those spelling mistake. Okay, so those are the type of we can do it. Okay, now these are the some of the prepare, but this is not limited, you can do multiple, but the generic or the standard preprocessing steps I have given you. Now question, why we wanted to do this? What is the benefit of text preprocessing, right? You must understand what is the benefit, otherwise why we should do, right? The first benefit is the it so it improve accuracy. What it will improve? It will improve the accuracy of your NLP model. Second, it improve the accuracy. Second, it reduces the complexity of data. Complexity of data. As it reduces the complexity of data, your model also ultimately learn faster. Because any NLP model or any model, it is what is the important task? To learn the pattern, right? So it reduces the complexity of data. What is third? It allows model to focus on the content. Allows model to most important content. Okay, most important content. Fourth, whenever there is a domain specific knowledge, okay, because all general knowledge has the general model like GPT, they have general knowledge. But if you go the domain specific knowledge like lawyer or medical, this data is not readily available, or finance or healthcare. Okay, so in this case, if you are dealing, then this steps is very important. Okay, in that case, this pre-processing definitely gives the one added advantage. Okay, so I hope you understand what are the benefits of the NLP. First is improve the accuracy, reduces the complexity of data, and ultimately model works better as it is understand the pattern easily. It allows model to focus on the most important content, and the in the domain specific data, this text pre-processing works very better. Okay, so I hope you understand till now what I have explained. Now as I explained this theoretically, so the next question comes, what are the tools are available? Okay, so I'll give one by one names of the tool. I would encourage, please research, please use Google, and the codes are readily available, or you can do the chat GPT. You will get the code, you can just run it on the Google Colab or anything. uh, so what are the, when I say Python, programming, so what are the libraries available? So in Python programming we have NLTK. Okay, this is called as a natural language toolkit. Okay, so these are the tools are available. Second we have so okay, let me tell you, the natural NLTK is open friendly open source library, and it perform various tasks. Second library we have sorry second library we have Spacey. Okay, Spacey. Okay, so Spacey is actually meant for the speed and easy use. Okay, as compared to NLTK. Okay, and it has a higher efficiency. Third library is called as a GenSim. GenSim. Okay, so if you want to do some kind of topic modeling or some document similarity or semantic analysis, encouraged to use the GenSim uh, things. Okay, uh, then we have text block. Okay, text block. So this text block specifically again derive for part of speech, then classification, extraction, okay, spelling correction. Okay, for everything this text block is also good. Okay, then there is a one more library called as a pattern. Okay, so specifically for web mining. Okay, this library is good. Okay, for web mining. Okay, the pattern Python library is used. Similarly, as you have, these are the library for Python, NLTK, Spacey, and GenSim. Similarly, you have some library for Java. If some of the Java developer using, or so who is familiar with the Java, okay, they can use this library called as a Stanford Core NLP. Stanford Core NLP. Okay, so Stanford has university has developed this library. If someone knows R and wanted to know which library is available for R programming language, so something called as a TM. Second is the co corpus. Third is the open NLP, and the fourth is the Spacey YR. So these are the library in R is available for the R library. Even there are some cloud-based APIs available. Okay, so let's understand some cloud-based NLP platform. So first is the Google Cloud Natural Language API. Okay. Second we have Amazon Comprehend. Sorry. And the third is the Microsoft Azure Text Analytics. Okay. So these are the some cloud-based libraries available. Along with that, we have some pre-train NLP model. Okay, majorly if you want uh, open AI API is available, so you no need to download any model locally. You just use API key and you can use. For example, GPT 3 and 4 you can use. Okay, you just require the API for the text generation or the translation. For this you can use this OpenAI API. Next is the Hugging Face Transformer. Hugging Face Transformer. So this is the uh, hub where you have many open source models are available for a specific task. You can download those model or you can also use the API. So that things they are giving. Now choosing a right NLP tool is very important. Okay, uh, and mostly it is depend on the project requirement, what is the complexity, what is the scalability. Okay, so it's varies project to project. It is not the fixed set of rule that you have to use this library only. Okay, it is all depend on the what kind of a nature of the project. Now if you see, uh, the question come, why we use Python, right? Okay, now why we, okay, why Python for NLP? The most important reason we are using Python for NLP is less code. As we have seen in my notebook, it really requires less code to achieve our main thing. Second important is that it has a pre-built libraries, has a pre-built libraries, and the learning is in Python. Learning is in Python, and that's why mostly use the Python. Again, platform independence means you can run this code on Mac, Windows, okay, Linux, wherever you want. Okay, and then the most important is that massive community support. Okay, many communities are working, so if you stuck in any issue, you have the massive community support. So that is the one advantage of using. Now there are many latest releases are available. So currently 3.13 or 14 is in the market. Okay, and many Python latest release always going on, so it's good. Majorly for this development Anaconda use. So in my previous video I have shown you how to install the Anaconda locally, so that you no need to have the Google Colab or something like that that I have shown previously. You can run all this code locally. So if you want to run all this code locally, you can watch my previous video how to install Anaconda locally, or how to run the Python code using the Jupyter notebook. Okay, so please watch that video, it will be easy, uh, and you can run locally. So some of the Python libraries you should know when I talk about NLP, and why use those library. Okay, so let's talk about that. The first library is called as a NumPy. Why we use NumPy? If you want to do some array processing, okay, or numerical Python, then use NumPy. Why to use pandas? If you want to do some data processing, then use the pandas. If you want to use SciPy, when to use SciPy? If you want to do some statistical uh, analysis or statistical manipulation, calculation, then use the SciPy. Matplotlib or the T-Bone, okay, uh, all these are used for the visualization. Okay, then we have scikit-learn. Okay, this scikit-learn is available for the machine learning. Similarly, we have TensorFlow API. Okay, so this is used for the deep learning. If you want to do the low level code, then go for the TensorFlow. If you feel this is very hard, you can use Keras for the high level. It's a high level API. Okay, so no need to go very deep code level. Then similarly, we have then NLTK, PACY, okay, then Gensim that I explained some minute back, right? And the nowadays very more famous library in the NLP, it's a PyTorch. Okay, the major thing it's popular because the it has a capability of GPU acceleration. It works very well with the GPU. Okay, and the deep learning libraries. So PyTorch is one of the another library. Similarly, NLTK has a corpus. Okay, corpus means some unique words. Okay, so you can check those corpus. Means it has a large text into that, and that text you can use for the corpus. Okay, so let me show you through the code so you can understand what do you mean by corpus. down. So the code, so from k dot corpus, not stopword, I want to import the, there are many corpus available, but I'm importing the brown corpus. Okay, brown corpus. So if I run this, so these many, so let me run. Yeah, oh, problem. Okay, I need to download this corpus first. It is not easily available. You first need to download, similarly like we did for the stopwords. Is download it, execute. Okay, so if you see, this brown corpus has these many words into there. Okay, adventure, bailers, letters, additional fiction. So this, like this we have 50 corpus, like brown is one of them, but you can use another corpus based on your requirement or research. Okay, similarly, as I mentioned, you can run the Python code in notebook locally. Similarly, you can use the Google Colab the similar way that I am using. The advantage of Google Colab, you no need to install anything locally, everything is running on the cloud. And the best part is that it's supporting the GPU, because our machine doesn't have GPU, right? But it has a GPU, so you will get the freely uh, available GPU. So if you go to this, okay, let me go runtime. I'm here. Click here. Okay, so are the change runtime type. Okay, so if you see, it has a CPU, GPU, and TP. If you are running very high massive data, I would encourage to use the GPU. But currently we are doing very small steps. No need to use. Okay, and it has some limit. If you want to higher, you can go for the GPU Pro edition. Okay, but basic task is achievable through this thing. Next is the web scraping. Web scraping is something you want to extract some data from the web page or the internet, right? So during that, you are doing the web scraping, and for that we have library in Python called as a beautiful soup. Okay, so these are the some code that you can use the tool. Okay, so let's say I'm giving some link of amazon.in, but let me say www.yahoo.co.in. Okay, so if I enter this, okay, let me copy this, my URL. Let me URL equal to paste this. If I enter, okay, if I want to check what are the text in my data, okay, you can see these are the HTML page get saved here in my request.txt, which has some HTML tags inside it, right? Now I want to remove this HTML tag. So these are the some line of code to remove the HTML tag. Okay, I use this function and then I run this function by passing my request.text. So when I pass this request.text here, it will remove all my HTML tag. So I'm using HTML parser for that. It is only giving me text out of this. So why we need a web scraping? It is very important if you want to do some analysis, some research, or some price comparison, some monitoring the news and social media, or building your own data set. Okay, so for that purpose you need a web scraping. Okay, because most of the time, uh, for the building a model you don't have enough data. So in that case you can do the web scraping of healthcare. Let's say you are building the healthcare system. Okay, so there are many healthcare websites is available, so you just copy those URL, pass here, do some HTML tag removal, and you will have the text with you, and then you do some NLP pre-processing task to build the NLP model around it. Okay, so I hope I have given you how to use this web scraping, and for that we are using the beautiful soup library. Okay, now we are coming to the our last stuff, that is the stemming and the lemmatization. I already explained why we require stemming and lemmatization to move the words into their base form. Okay, so what actually it will chop the suffix and prefix. Okay, so let's understand the stemming first. Sorry. So in stemming, what will happen? It will convert into their base form. So it will remove some suffix or prefix. Okay, okay. So for example, let's say this is my stemming. Okay, so what is their base form? Stem is the base form. Okay, but in the problem in the stemming, it is always not convert into the real word. Okay, it will not convert the real word, but the stemming is the very important in the use case where you require a speed. Okay, it is very useful where you require speed or where you require efficiency. It doesn't matter the word is a real word or not, then that case you are using the stemming. In the lemmatization, use the lemmatization when you want to convert the word into the real word. Okay, so lemmatization is useful where the accuracy is important. What? Accuracy is important, your grammar is important, or your main word is important, right? So that time you are using the lemmatization. So accurate representation of word is achieved through the lemmatization. Okay, now I hope you understand where they use lemmatization. For accuracy, use lemmatization. For speeding and handling the large data set, so let's say if you have large data set, go ahead with the stemming, or you can use the combination of both. Mostly people use the combination of both stemming and the lemmatization. Okay, the next is the feature engineering, but that I will cover in the next lecture in detail. I hope this lengthy explanation uh, you understood very well. If you have any doubt, anything, please feel free to do the comment section. If you want any more depth explanation, please let me know. But thanks for watching till end. See you in the next lecture. Thank you.